If you want to make a Lorenz curve using Python instead of Excel, you can go to my GitHub website. So it's drstephpowers.github.io/econ-in Python. So econ in Python. And there's a link to my GitHub website in the notes for this video. So if you're going to create a Lorenz curve using Python, we go here where it says Lorenz curve, and it will take you to Google Colab. And so what you can see here, it sometimes has trouble loading, but this little icon right here is a link to Google Colab. And so you can do your Python coding here in Google Colab. So we'll click on that, and it opens up a Python coder in your Google Drive. And so in order for you to be able to do this code, you'll need to sign in to your Google account. And you can copy this file to your own Google Drive so that you can amend it and save it for later. So we'll walk through a 2014 Lorenz curve. And if you're taking a course with me, then you're looking at newer data and doing a comparison. So we need to sign in to a Google account in order to work through this. And so I'm just going to flip here to one where I have signed in. So if we're creating a Lorenz curve, we are looking at income distribution across the population. Here we have data for Canada and for the US. And it's divided into quintiles, so 20% chunks of the population. What this table shows you is that the poorest 20% of the Canadian population have 7.2% of the income, and the poorest 20% of the US population in 2014 had 3.1% of the income. So it's cutting the population into 20% chunks. Now we want to create a Lorenz curve which graphs the population versus income. And we want to show that as you increase the amount of the population from 20% of the population to 40% to 60% or 80%, how much of the total income is being captured. And so we're going to need to take this data here that's in quintiles and find cumulative income. So we're going to need to know, for example, what 40% of the population have in terms of percentage of income. To do that, we would add the lowest quintile, so that's 20% for the poorest, and the second quintile, that's the next 20%, to find out how much the poorest 40% of the population have in terms of income. So we'd add 7.2% to 13.1%. All right, so let's dive into this in Python. So in Python, because we're going to be graphing, we're going to need a package called matplotlib.pyplot, and we're going to import that, and then we're going to shorten that and just call it PLT. Okay, so import matplotlib.pyplot as PLT. And then we have our data from the table above. So here we have our Canada 2014 data, and all I've done is put it into the decimal form. And you can see it's the same information that was in the table above. Do the same thing with the US. So US 14 here, and we have our percentages. Now we're going to graph against the population. And so the population is going to go from 0 to 20% to 40% to 60%, and so on. I'm just going to make this a little bit bigger if I can here, just so we can make sure we can see that no matter what kind of device you're watching this video on. Now, we want to plot the extremes, imperfect and perfect equality. So what does perfect equality look like? What does perfect inequality look like? So perfect equality means that everyone has the same amount of income, which means 20% of the population has 20% of the income, and 40% of the population has 40% of the income, and 60% has 60% of the income. So you'll notice here that when we look at our perfect equality and our quintiles here, we have that they're the same numbers. So we plot those on a graph, we'll get a nice 45-degree line. Perfect inequality, or really it is imperfect, is going to be the other extreme where we have that everyone has $0 and one person has all the money. So if you're graphing that, we want to show that as a line where 20% of the population has nothing, 40% of the population has nothing, 60% of the population has nothing, and so on. If you put it into a graph, whether in Excel or in Python, and you made that last number 1 to represent that the last group has all of the income, the problem with your graph is that between 80% of the population and 100% of the population, you get a graph that had this line shoot up between those. And to truly show perfect inequality, it's the very, very last person. That not 80%, not 90%, not 97%, but that very, very last person who has everything. And so on a graph, we're just going to represent that as 0 all the way, just to make it a bit clearer. All right, so we have all our information here, and we are putting it in as lists, so we have our parentheses around there. And then we're going to plot. So the way that plot works in Python is we do plt.plot, and then whatever is going to go on your horizontal axes, which here is going to be our population. So we have our 20, 40, 60, 80% from those quintiles. And then whatever goes on the vertical comes next. And then here we're going to have dots. And so we tell it a marker equals with that little 0 there so that we can, or it's actually an O, so that it knows to put the dots. So the first line there is going to plot perfect equality, the 45-degree line, by plotting our numbers that we see here, quintile, and our perfect equality, and you notice those are exactly the same numbers, which gives us then this 45-degree blue line. The second line of our code here, it takes those quintiles on the horizontal axis, so that's our population, 20, 40, 60, 80, 100, and is plotting our perfect inequality, we called imperfect here, with all those zeros. And that gives us this orange line that you see here, so our two extremes. So if you're doing Python coding, what you're going to do is you're going to tell it to run. And so when I run this code, first I import. That's the little circly wheel we have here. And then I'm going to input my data. So I'm going to run each of those lines of code. And once it has that information, then I can create this plot. First, I tell it that it's going to have two lines, one for perfect and one for perfect equality, one for perfect inequality. Then this third line here is going to give me a label on the x-axis, which is this population label you see here. And this y label, that's the vertical axis label, is going to say cumulative income. I've added a legend here so I know what color represents what. The blue is perfect equality, the orange is perfect inequality. And the rest of this code here where it says bbox to anchor is simply telling it that I want to shift it down below the graph, that's the negative 0.15, and I want to shift it over, so I don't want it to be just butting up against the edge of the image. So I have moved it a bit over, so it's underneath kind of the center more of the graph, that's the 0.75. And I've made it two columns. The perfect equality and perfect inequality can be on the same row in my legend, and so that's two columns. As I add more lines to this graph, I can decide for my legend if I'm going to add a third column or if I want the additional information in the legend below. So I'm going to run this and we'll see it create exactly the same thing that you just saw on the screen. Okay. Now when it comes to that legend, the name order is the same order at which you are plotting. So that first plt.plot is the perfect equality, and the second plt.plot is the perfect inequality. So if I add additional rows to plot additional lines and curves, I would just put here a comma and add my additional labels for them. Okay, well, we want to plot Canada and the US against these extremes. So we need our information here from Canada and the US, but we need it to be cumulative. So as I said before, we need 7.2 and 13.1 to be added together so that at 40% of the population, we can see that just over 20% of the income is covered. So to do that in Python, we're going to create a little loop where it's going to perform these calculations for us. So we're going to start by creating an empty matrix. So we got some hard brackets here. And we have we'll call it cumulative Canada. So cumulative Canada. And we're going to start with an initial value of 0. And then we're going to create a loop that is going to go through all the values in our CAN 14. So you'll remember up here we had CAN 14, had the different percentages. And what it's going to do is it's going to go through each value in that CAN 14, and it's going to add the new value to the previous value. That's the initial plus equals I. It's going to go through and it's going to take, as we said before, it's going to take our 7.2% and add it to the 13.1%. Now, if we just left that loop as is, it would just add all of these numbers together and we get 100%. What we want, though, is we want to capture those steps in between where it adds 7.2 to 13.1. And then we want the value where it adds 7.2 to 13.1 and 17.7 so that we get those cumulative amounts at each point. So that's why we have this cumulative Canada.append, and that's each time it's going through the loop and adding the next value in the CAN 14, it's going to capture the total. And so that append means to take that calculation, whatever you got as output, and put it in to this empty set we have here for our cumulative Canada. And so it's going to then put that together. So if I run that and then call it, okay, so tell me what you got. What you get is the values, the total values. So first when you add 0 and 7, you get 7. When you add to that then the 13, you get the 20. And you can see then as we add each additional point, we get up to 100%. Now, I want my graph, though, to start at 0, not at 7. So I need to add a point before. So we're going to use the line here, or the command, insert, to insert a 0 at the beginning of the list. And so the location is 0, and the amount we are putting in there is 0. So that's what this is here, is that it is adding a 0 to it. So that when I then, if I were to call it again, you'd see it's the same numbers as before, but I now have a 0 in front. Okay, and that's so when I go to graph it, it starts the graph at 0. So I have the same command for the graphing as I did before, with an additional row here to represent our Canada data. Okay. And I've added here a label for Canada. And if I want to put all 3 labels on the same row, I need to change the number of columns to 3. If I leave that as 2, it's going to put Canada on the second row in the legend below the perfect equality. Okay. And so we could run that. And we can see here the Lorenz curve for Canada. Now add the US to the graph. So repeat the same process, create that same loop where you are now looking at the US data, and then add it to your graph. So we would go here, and we're going to still need the same starting point. Okay, we're going to, this time though, this is the US, so we're going to call this US. Okay, but we need to start with an empty set and initially have it set at 0. Then what we need to do is we need to go and take our loop, and this time we're going to loop through the US 14 data. Same process where we want to capture each of those numbers that are totaled as we go through the list. So we do that. We can check it here. We can say, what do you get here for cumulative US? It's going to have the same problem that the Canadian one had. So let's just check here. 3-1, and then it gets 11-3. 3.1 plus 8.2 gives us just over 11, so we can see how it's adding through. But it's got the same problem that the Canada one has, is that we want to start it at 0, and it is not. So we're going to need to insert in here a starting point of 0, and we want, when in Python, when it counts the number of words or occurrences, it starts as counting at 0 instead of at 1. And so your first item here in your list is always number 0 as opposed to number 1. So just a tricky thing to kind of remember is that it doesn't start counting at 1, it starts counting at 0. All right, so let's do that. We can double check it here by looking at our cumulative US. Now it's correct with our 0. And then now we're ready to draw our graph. So we're going to take that same code for graphing, and we're just going to add a row in there for the US. Okay, so it's really going to look a lot like this Canadian one. It's just going to say US instead. Okay, and then I want to make sure I add a label for it. Okay, and I need a parentheses in front and behind. And I can decide if I'm going to have, let's just do 2 columns, because now we're going to have a second row where Canada and the US have their labels. So let's take a look at this. So you can see in the legend, we have perfect equality, inequality, Canada and the US. And you can see Canada in green and the US in red. And you can see how close they are to the blue, which is perfect equality, and the orange, which is perfect inequality. So you can see which country has greater equality, closer to the blue line, that would be Canada. Which one is closer to perfect inequality, closer to the orange line, that would be the US. So we can compare the distribution of income and income equality between countries by comparing them to each other and to the 2 extremes. You could repeat the same process with 2019 data and look at, has it changed? How does Canada compare to the US? And you could also compare the 2019 data and the 2014 data if you wanted to add them all to the same graph to see if there's been any change for Canada or any change for the US. So give that a try inside this Google Colab, where you can copy that same code you had before and you can apply it to your new data. Follow the same steps we just did. You can, if you right click, you can copy this image and you can paste it into a Google Doc, a Word doc if you're submitting it for an assignment.